Hello everyone, my name is John from Vulgar Kitten Studios, and welcome to part 3 of our third-person shooter tutorial. So what we're going to do today is we're actually going to set up our player controller. So in our scripts folder, we have this character motor, which has already been pre-configured for us. Now, one thing to take note of is this motor is responsible of handling how the player moves. Our controller is actually responsible for moving the controller. So that's the distinguishment that we need to make between these two scripts. Alright, so let's go ahead and open up our player controller script, and I'm going to open up my regions and get those all opened up, and we'll start out with some using statements. One using statement. We're going to be using our globals namespace, so we'll just put that in up there so that way we can have access to our inputs. And we're also going to want to require some components because we don't ever want this script to be attached to anything without its dependencies. So in square brackets, I'm going to go ahead and type require component, and we'll use the type of, and we'll want to require the type of character controller. Alright, so we always want to have a character controller attached. Now in our player prefab, we actually do already have a player control or character controller attached, but just for demonstration purposes, I'm actually going to remove that. So we'll remove the component, and we'll come back in here, and we'll just complete the list of dependencies. So I'm going to require component, type of, and the type of controller that we want is the head look controller, and we'll require component, type of, and we'll want our character motor script, and also we're going to require in our own scripts as well. So require type of, and we're going to require in our player animator. And I don't actually have this in my notes as a requirement, but we are going to be attaching our gun script directly to the player object, so I'm going to go ahead and require that in as well. So we're going to require in well, not gun, but weapon, the weapon class. Okay, so now that we have those requirements in there, let's go ahead and come back into Unity, and we'll wait for it to compile. And now we'll go ahead and just drag our player controller script onto our player object in the hierarchy here. So I'll drag that on there, and now we can actually see that our player animator, character controller, everything that we put in our require list is actually attached to our controller. Okay, so I'm going to move this character motor, or the character controller, I'm going to move that up one, and I'm going to move the character motor up one as well. And I actually might as well go ahead and do that for the head look, because I just like to have that as an organization priority. So that's going to be our component list for our player. And while we're going ahead and adding in scripts and everything, we might as well do that for the camera. So I'm going to come into the player and find his camera object, and well, the the player camera script is actually already attached on mine. Again, it is actually empty, so if you don't have it attached, go ahead and attach it now, but it should be already attached, it looks like. And also I'm going to come into prefabs, and I'm going to grab my player target HUD, and I'm just going to drag that into the hierarchy and zero out its position. And on here, I'm going to go ahead and drag on my player target script. So that way all of our behaviors should be set up automatically for us. Alright, so we'll come back into our player controller script, and we'll continue this out. So I'm going to make some public variables. So I'm going to make a public float called idle timer, and I'm not going to initialize it. I'm going to make a public float called run speed, which I'm going to initialize to 4.6f, public float run strafe speed, which I will initialize to 3.2 07F, and these values I'm actually gotten a reference to use these, but they are exposed, so if you want higher or lower values you can adjust those to your heart's content in the inspector. Alright, so we'll need public float walk speed as well, and we'll make that equal to 1.22F, and public float walk strafe speed, which is going to be equal to 1.22F, and public float max rotation speed, which is going to be equal to 540F. And I'm just going to go ahead and line up my equal signs, which should be something like this. And that's not necessary. You don't actually have to do that. Like I said, I just like to do it. It keeps my code cleaner. And now I'm going to create some public variables that are actually going to be hidden in the inspector. So I'm going to make a comment here and say public variables that are hidden in the inspector. And if you want to do this, all you have to do is in square brackets above your variable type in the hide in inspector flag, and that will make it unserialized. So we'll go ahead and public float target y rotation and just end that off. And again, I might as well actually just copy this, so I'm going to Control C that and come down here, and we'll make a public bool called walk, and we'll need one called public bool in air, and public bool aim, and public bool grounded. Now these are just true-false statements that are going to determine what state a certain part of the controller is in, and then we can actually set up on the controller's very specific behaviors based on these states. So if you have your reloading or running or rolling or defending, dodging, whatever, you would put that in this list of bools and adjust your logic however you wanted to. And finally, I'm going to make one more hidden public vector 3 this time, and we'll call it move dir for move direction. And that's it for our public variables. Now we'll need a couple of private variables. So I'm going to make a private transform and call this player transform, and we'll make a private character controller and just call that controller, and we'll make a private character motor and just call that motor, like that. And we'll come down to our start method and just initialize a couple of things. So we'll set our idle timer by default to be equal to 0, and we'll take our player transform and make that equal to this transform. Just for a little bit more efficiency, we're going to cache our transform so we don't have to look up that component every call. And we'll set the walk boolean to true because we want to be walking by default, and we'll set the aim boolean to false. And now we'll go ahead and assign our components. So we'll set our controller to be equal to get component character control, or not character motor, but character controller, and we'll set our motor, this one we'll set to get component character motor, and just line that up like that. And finally, I'm going to set my controller dot center to be equal to a new vector 3, and we'll set 0f for the x and 1f for the y and 0f right here. And this is going back to the position of the character controller that I had mentioned in our setup video. So if we go ahead and take a look at our player and we expand our character controller, then we can see that it's actually resolving to the central point of the player, not where we actually want it. So at runtime, we're just going to bump that up one, and like I said, we can just do that from here and it would change its position, but just to prove that it works in script, I'm just going to leave it at 0 right there. And you can do that for if you have shorter or taller models. You can set up a vector 3 in your script to adjust the central position, height, or whatever properties of the character controller that you wish to manipulate. And we'll come down into our update method now, and we'll go ahead and start working with this. And as a matter of fact, what I really want to do is I want to set up a custom method first. So I'm going to set up a private void and call this get user input. And in here, we're going to handle all of the input that the player gives us. So we're going to say aim is equal to input dot get button, and this is going to detect if we're holding the button down or just press it one time, regardless. So it doesn't just detect it on button down or button up, it detects it as long as we are pressing it down. And we're going to say player input dot fire 2, like that. And that is again coming from our global script over here. So fire 2 right there. And this is going to return true or false. We're also going to set the idle timer to be plus equal to time dot delta time. So that way we're pretty much always increasing it if we are idle. And we're also going to set walk equal to a bit of a confusing little line of code here, but just bear with me. We're going to say if not input dot get button, and we want to use the player input dot run. So as long as we're not pressing shift, then we are going to be in walk. And we're going to say or our move direction is equal to vector 3 dot 0. So if our move direction vector is actually zeroed out, then we are going to set walk to be equal to true. And then we're also going to say or our input dot get axis, and we want to look for the player input dot vertical axis, and we're going to say if that's less than 0. So if we're holding back on our input or hitting S or the back arrow key or holding down on a left thumbstick of an Xbox controller or something, anytime that we're moving backwards, we want to be walking. We don't ever want to be running if we're going backwards. And that's pretty much, I mean, there are some games that allow you to run while you're going backwards, but generally speaking, most games only allow you to walk when you're going backwards. So that's what we're going to do here. And we're going to call that method in our update function. So we'll say get user input, and then we're going to say if not motor dot can control, and this is coming from the character motor script, and we'll say if that's not true, then we actually want to set that to be equal to true. And this just ensures that we actually can move at runtime. And now that we've done that, we'll go ahead and set our move direction vector, and that's going to be equal to a new vector 3. And we want to check for the input dot get axis player input horizontal for the X, and we're going to say 0 for the Y, and input dot get axis player input dot vertical for the Z. And just go ahead and bring this down to the next line, and we're going to say if our move direction dot square magnitude is greater than 1f, then we're going to say move direction is equal to move direction dot normalized. So we do actually only want to return a length of 1. Alright, and this is just to ensure that if we're holding let's say left and up at the same time, we're not going to be running at a faster speed if we're moving in a diagonal direction than we would in just a single direction. And we're going to go ahead and say motor.input input move direction. We're going to say that's equal to player transform direction, and we're going to use the move direction vector to feed into the transform direction method. And then we'll say our motor.input jump is equal to input.get button down. So if we're pressing the button down, our player input.jump. And now we'll set our motor.movement.max forward speed to be equal to, and here we're actually going to use a ternary operator, and we're going to say if walk, and so if our walk boolean is true, then we want to set the max forward speed to walk speed, or let me just get the IntelliSense right, walk speed, else we want to use run speed. Okay, so if you've never seen a ternary operator before, that's what it looks like. It's just an inline if statement, and you can nest these however you want, and you can even actually use them within the conditions of an if statement. Ternary operators are extremely useful. Now we're going to say motor.movement.max backward speed is going to be equal to motor.movement.max forward speed. And we'll say motor.movement.max sideways speed is equal to, and again we're going to use our ternary operator, walk, and if that's true then we're going to use walk strafe speed, otherwise we're going to use run strafe speed. And now we can go ahead and say if move direction, I don't even know what that was, move direction does not equal vector3.0, then we want to set our idle timer equal to 0. So that way we can reset our check for how long we've been idling. And we'll set the in-air boolean equal to not motor.grounded. And actually we probably could only use one boolean, but if for some reason we want to split the functionality between the two, we're going to go ahead and set our grounded to be equal to not in air, like that, which, you know, this is a little bit of redundancy here. I'm not 100% sure what my thought process was by putting it this way, but we have it now, and that's how I'm going to leave it. And we're going to go ahead and create a float, and I'm going to say current angle, and this is going to be equal to our player's transform dot local rotation dot Euler angles dot y. Alright, so we've gone ahead and cached this, and you might be wondering, why are we caching the y local rotation from the player's Euler angles? Well, the answer is pretty simple. What we want to do is actually set the local rotation. So we actually need to do some calculations prior to doing that, because unlike JavaScript, we can't just set the local rotation or just set these parameters here, such as the x, y, and z. We actually have to set the full local rotation equal to a new vector3, and well, you'll see as we finish this out. So let me go ahead and I'm going to make a float, and I'm going to call this delta, and that's going to be equal to mathf dot repeat, and we're going to use the target y rotation minus the current angle and 360 degrees, and then we're going to say if our delta delta is greater than 180, then we're going to set delta subtract equals 360. And then we'll say float new y rot is equal to math f dot move towards, and we want to move towards our current angle, and our current angle plus our delta calculation, and time dot delta time multiplied by max rotation speed, and I already put my semicolon there, and then we'll go ahead and set our player transform dot local rotation is equal to quaternion dot Euler, and then we'll use our new y rod here. So what we're actually doing is we're checking for, or well, what is this? Okay, so I put in a float here. I actually completely skipped a calculation. Sorry, I just kind of zoned out. Alright, so we're going to need to actually create a vector 3 for our local rotation. So we're going to say new local rotation, and that's going to be equal to a new vector 3, and we're going to use the current player transform dot local rotation dot Euler angles dot x, and we're going to use the new y rot for the y, and our player transform dot local rotation dot Euler angles dot z for the z, and now we can pass in that vector 3, which is going to be new local rotation, like that. Okay. So this is actually responsible for rotating the character, but as you see, we can't just do this all in one line of code. We need to split the calculations up into different variables and then just bring it all together down here. So really it's just a lot of code to get one thing done, and so don't let that frighten you off. And that's pretty much everything that we need for the player controller. Let me go ahead and come back over to Unity and let this compile. We shouldn't have any errors. And we don't, so let me go ahead and play the game. And first thing, hope we don't fall through the floor. Okay, so we don't. And it's wanting us to assign a target to the head look controller. So I'm going to come over to the player here, and matter of fact, I'm just going to go ahead and turn off the head look controller for now and go ahead and play again. Okay, so now if I start moving around, then we can actually see him start moving around, and it looks like he's playing his fall animation here, but that shouldn't be too much of an issue. We'll address that in a few moments. Alright, so we can't do any rotations yet, and that's because we don't have our camera set up yet, but we'll get to that in the next video. Let me go ahead and stop the game here. And as a matter of fact, that should be it for this tutorial. Actually, one more thing before I go. We really shouldn't be working with the animator yet, but I'm just going to go ahead and open this up, and we'll take care of the falling animation right now. And so I'm just going to go ahead and open up all of this stuff here. And actually, let's go ahead and just take a look and see why that's happening. So I'm going to go ahead and hit this. I'm going to come into the animator, and I'm going to tick on grounded. So we'll come back over to our scene or our game, and we can see that he's no longer falling. Alright, so what we actually need to do is set that in script just to make sure. So I'm going to make a public animator variable here, animator, and just call that animator. And in our, well, we'll actually need to make sure that we're using our globals, so we're using globals. And in our update method, I'm just going to go ahead and say animator dot set bool, and use the animator condition from our globals. grounded, and I'm going to set that equal to, and we're actually going to need player controller as well. So matter of fact, I could probably just make these private. I'm going to make private, well, first of all, because I like to set my private variables up to have underscores, I'm going to go ahead and do it like that, and just copy this down to my private fields and set it to private, and private, well, player controller, and player controller to name it. And in start, I'm going to say animator is equal to get component animator, and player controller is equal to get component player controller, and then we'll set the bool to player controller dot grounded like that. And now the grounded condition should be whatever our player controller is. So come back in here and come back over to our animator, just tick this back off and come back into the game, and there we go. So now I'm going to check in the animator, and well, that's interesting. It's definitely not on, but that's not being reflected in the window. Probably just an editor issue that happens at runtime, but we can clearly see that his falling animation is not playing, meaning that our grounded variable is being checked on. Alright, so thank you for watching, and I will see you in the next video when we start setting up our camera. Have a good one.